So, welcome to today's lecture. And in the previous lecture, we discussed the requirements elicitation, and how to write requirements document. And as I also mentioned, that requirements documents are the end product or the final product of requirements engineering process. But requirement document also have a condition that it needs to be high quality and correct. So that's why the requirements validation is important. And I will show you the same picture that we discussed before, that requirements validation is basically a pre-step of requirements document generation. So you can stop me also anytime before during the lecture, and the slides are also in Moodle. And if you need to follow the slides remotely, you can have the slides from there. So today is the second lecture on requirements validation and management. We still have two that will be basically on the tools and modeling practices. So requirements validation. So what is requirements validation? So it's basically checking of the requirements that we already elicited or analyzed. And the goal is to make sure that requirements are have high quality, and we also want to discover problems within the requirements, and we want to correct them before we write any requirements document, because that will be the final document that the developers will be using for the development and implementation. So we need to make sure all the problems are corrected before it is in the developer's hand in the requirements. So who will be involved in the requirements validation? So in practice, or it should be basically all the stakeholders, or at least the representative of the stakeholders in the requirements validation. But it's also better to involve other people in the requirements validation who were not part of the requirements elicitation, because it will be a kind of neutral view or neutral analysis of the requirements. So if you already we should involve stakeholders, all the previous stakeholders, as well as we should have people from requirements engineering team or even system designers, because these requirements engineer people or system designer people, they may not directly elicit requirements or state the requirements, because requirements are coming mainly from the end users and also the customers. So you should have people of different background. So what are the common problems of the requirements? Because since we are validating the requirements, that means we are looking for problems, of course. So the main or major problem is the lack of conformance to the standards, because as I mentioned, there are standards called ISO 9001 or 9003 2018 for software engineering, or even the US Department of Defense standard for requirements engineering or requirements engineering process, that tells you how to write requirements and requirements document. So the lack of conformance to the quality standards is one of the main problems for the requirements validation or requirements. And also the very general problem of poorly written requirements, because usually poorly written requirements are ambiguous and hard to understand, and not easy to get for the people who were not part of the requirements elicitation. And then also the requirements conflict, because there should not be multiple requirements that are conflicting each other. That means you have a requirements.
Sorry, Francis.
Yeah.
Are you sharing the screen? They can
Yeah.
see you on Slack?
Yeah. I think, yeah, now I shared, so that's why. So the requirements conflicts is another problem that is very common. So multiple stakeholders are proposing requirements, and there might be conflicts among the requirements. So these three are the common problems of the requirements. But these problems must be solved before you move to basically the final state, that is the requirements document. And it's important to solve at this point of requirements validation, because if you already produce requirements document, it will cost you more if you bring this problem into the requirements document. So you basically have to go to the through the whole process of requirements elicitation, analysis, and negotiation if you don't avoid these problems. So as you remember this image from the previous lecture, so we have requirements elicitation and specification and analysis phase, so on the left, and on the bottom we have the final outcome of the process, so that is the requirements document. But before that we have this a checkpoint, that is requirements validation, and it's basically a manual validation. It can be automated, but of course those automated systems are based on some manual checking, and the principles behind it are manual stuff. So it involves not only feasibility studying, but the main thing for the validation is prototyping and reviews. So that's the two things we will be focusing in this lecture more. And to understand the requirements and to check or to see if the requirements are correct, you need to have a visual representation of the requirements. So prototyping is good for that. So let's go back to the requirements validation. So we already discussed or described what is requirements analysis, right? But we also just defined what is requirements validation. So both are dealing with missing informations, conflicts, omissions, ambiguous way of writing requirements. So what's the difference between requirements analysis and validation? You have any idea? So even from a textual perspective of view or natural perspective or common sense, so what's the difference between requirements analysis and requirements validation? We are saying that they are dealing with kind of similar things. So they are omitting, they're finding omissions, they're finding missing informations, they're finding conflicts. But what's the difference between them? Any idea? Just from the basic idea, from the basic sense. So it's kind of tricky because requirements analysis and requirements validation. So if you remember the picture here, so requirement validations are done mostly in this phase, so in the later phase, and requirements analysis are done in this earlier phases. So in these earlier phases, requirements are incomplete, they are raw requirements, there can have problems, so they are unstructured, and it can be also written in informal way. So when you are doing requirements analysis, you are dealing with requirements that are not really well written. But when you are doing the requirements validation, now you have more complete requirements. So you have identified incompleteness within the requirements or inconsistencies, and you remove them. And the goal of requirements validation is that whatever you are going to write in the requirements document, it is written well and it conforms to the standards. So that's the main difference between the requirements analysis and validation, because requirements analysis deals with the raw requirements that has more problems in their writing or in their specification, and the requirements validation deals with the final draft of the requirement. So discovering and of course fixing those problems can avoid a lot of expensive rework, because if you don't identify them before you are writing requirement document, and you are in the development phase or you are in the delivered phase, it will cost you more money than to repair them or resolve them during the requirements validation phase. And there is research, and many research in fact, that shows that if there is error in the system or the program that you delivered, it's 100 times more than if you solve it before the requirements document or during the requirements validation phase, and if those errors are mainly due to requirements error. So that's the point that here is that you should not have errors in your requirements, and it can cost much more than if it's already exists in the delivered system than if you repair it or resolve it during the requirements validation. So we need to find those errors as early as possible, basically. So one of the part of requirements validation is to ensure that requirements document meets standards. So as I mentioned earlier, there are three problems. So one of the problem is that it doesn't conform to the standards, and if it doesn't conform to the standards, that means it's hard to follow and it's not well structured. and sometimes not consistent. So there is benefits of checking these standards. So if our requirements or requirement documents are following any standards or not. One of the most earliest and most easy benefit is a cheap way. So if someone or maybe one single person is checking the requirements document or requirements specification against a standard, it might take longer, but it doesn't take too much money or budget to check the standard conformance. And also, if someone is checking the requirements against a standard, it will somehow reveal some problems. So it's a easy way or cheap way to find problems within the requirements. But who should perform this standard check? So anyone who was not part of the requirements elicitation. It can be an analyst, it can be a requirements engineer, it can be any stakeholder who has good understanding of requirements. And the reason is that not to be biased when he is looking at the standard and the requirements both, and he or she can do it unbiasedly, basically. So how to perform? So basically, the analyst or the engineer who is performing this check, this standard conformance check, he will check individual requirements and the requirements document itself before it's a final version, of course, that the structure that the requirements we are following or it has been followed, it conform to the structure that is proposed by the standard. And he can mark or note or highlight missing and problematic sections. And also another basic thing is that he need to check that all the pages are numbered. So especially the diagrams, tables, and figures, they're labeled, and no other requirements are kind of incomplete, or it's not to be to be completed requirements. So all the requirements should be stated as a completed manner. So they should be self-descriptive, basically. So if we found any problems with the or any deviations with the standards, so what should we do? So the first thing is, if we have enough time, we should return the requirements or requirements document or specification to the requirements engineering team to correct the deviations. That's the maybe the longest approach, but most effective approach, because it will ensure that you refollow all the procedures and processes, and you redo your whole work. And also you can, as a reviewer of the requirements with the standards, you can note the deviations. So you can write down, or you can basically mark the requirements with the problems and distribute it to the requirements reviewers. So you are at this point you are checking the requirements if it meets the standards, but you did not really check if the requirements itself are technically correct or not. So what you can do, you can mark those deviations from the standards that these requirements did not meet, for example, certain structural constraint. You can mark it and send it to the reviewers. The good thing is that it will save time and cost of creating the whole new version that you are doing in step or in the phase 1 or in the option 1. But if the deadline is tight, so you have to deliver the software within, let's say, 1 week or 1 month, and the errors that the guy who was changing the who was checking the standards, and those errors are minor and it will not affect technicality of the requirements or the understandability of the requirements, you can also go for option 2. So you don't need to create the whole document again. So you can just mark it down or note it down and send it to the reviewers. So in addition to the checking with the standards, we should also inspect the requirements formally. So by formally, I mean the inspection team or people who will be part of this inspection will formally meet, and they will discuss the problems, and then will agree. They will agree on the set of resolution. and that's why it's called systematically check. And people who are participating this team should be from different backgrounds, because people will bring their own skill, knowledge, and ideas, and their also own perspective. So the benefit is that it's also a cost-effective way, because you still did not implement your requirements. You are just analyzing the requirements as a team, and it will be basically a good way of not doing the whole work again. And this is not only applicable to requirements or requirements document. It can be done in the same way for user manuals or user documentation or system design, or even for the code. So we can discuss as a team everything. And also, since this meeting is a neutral meeting, so by neutral meeting I meant so people from different background and skills who may or may not part of the requirements solicitation or requirements analysis can join this meeting. So there is no blame game. So if there is a problem with a requirement, no one can blame who proposed this requirement. And that's why conflict can be or any resolution can be done between the stakeholders without any fighting or confrontations. So basically it should not be a blame game. So people should accept whatever changes need to be done. And also the requirements inspection, as I mentioned, it's a formal or systematic check. So it's a formal meeting. So the guy who will be leading the meeting should not be also part of requirement solicitation. Again, it's a goal to not to bias them or not to bias their view while they are inspecting the requirements. And a requirement engineer who may or may not part of the elicitation process present each requirement to the people, and they can discuss and record the problems in a sequential way. So there can be multiple problems in particular for the requirements, and what could be the actions for those problems. So one of the problems, of course, can be the most simplest and common, the clarification problem. So requirements could be written badly, so there is no alternative way to deal without rewriting it. So the requirements might be important, so you cannot avoid it in any way, so you have to rewrite it. And also the missing information. So most of the time requirements might not be well defined due to some information that were missed unintentionally. So what requirements engineer can do, they can talk to stakeholders to find this kind of missing information or to fill these gaps. And then there is, of course, the requirements conflicting, and you should resolve this kind of conflict by negotiating or discussing with the stakeholders again, because two stakeholders might not agree on the same requirements, so there is no alternative without negotiating them. And also finally the unrealistic requirements. So this requirement sometimes may be made realistic by either modifying them, but if they are not modifiable, you simply have to delete them, because those are not realistic in terms of maybe implementation, maybe in terms of deployment, or in terms of even usability. So these are the four actions and their corresponding these are four problems and their corresponding actions for the requirements problems. So as I also mentioned before, the review team should be multidisciplinary, and by multidisciplinary I mean it should be people from diverse background, and it of course have some benefits. So those people include system end user or end user representative. So it can be also a customer representative. So if you again think the banking financial system, so the end user and the customer are not the same here. And also one or more domain experts who has financial knowledge, and engineers will be developing or designing the system, so they also need to be part of this review team. And one or more requirements engineers, because requirements engineers will basically talk to the end user. They will transform these requirements from the end user that are high-level text, and they will represent it in a way that developers or software engineers will understand to design it or implement it. So people from all kinds of background should be in the team. So as I mentioned also before, that the main benefit is that people from different skills, people with different knowledge and experience. They will be part of this review. And also, not everyone have the same understanding of everything. So, for example, a domain expert might not have a good knowledge on requirements engineering or software engineering aspect. So if they are part of this team, they might also develop understanding of what's the perspective or what's the view of engineers or requirements engineers on a particular requirement. So they can develop their understanding as well as an individual entity. And also, there is another way. It's a very formal way of validating the requirements. So it's basically through the checklist. So what you do as a checklist, you identify critical attributes of requirements, and this will also help. So these critical attributes for the reviewers or readers, what they should look for in the requirements or in the requirements document. So I will give you an example or the questions that we should ask when we are defining a validation checklist. But one of the good benefit of this validation checklist is that it basically gives you a structure, a formal structure of the validation process. So if you don't have any checklist, you don't know where to start and how to proceed. So it gives you a well-defined process or structure to for the validation. And also, if there are people in the team, in the review team, who are doing the validation and they don't know anything about the requirements or about the system itself, they can follow this checklist as their starting point, and they can feel themselves that they are able to do so. So they might got lost when they are reading the requirements or when they are performing the validation. This checklist can help them. And also, particularly, it's important for, or this checklist is useful for managers and end users, because they also most of the time don't have technical knowledge on the system, from the system perspective, and how to validate the requirements that they themselves expressed, in particular the end users. So this checklist will guide them on how to validate the requirements, not only their requirements, but also requirements from other stakeholders. So this validation checklist is always concerned with the quality principles of the requirements document as a whole. So if we apply this checklist not only to requirements but also the requirements document, it will ensure that the requirements and the requirements document is of high quality. So what are the questions that we can ask for each requirement to validate it? So the first and the most common question is, are those requirements, or is individual requirements is complete? So we have to check if there is any missing requirements, or is there any missing information for individual requirements description, because as a single statement or as a whole, the requirements should be always complete. And then also the requirements should be consistent, so there should not be any conflict with other requirements for sure. And then it should be understandable, so anyone from any background can read the requirements and should understand the requirements. And also it should not be ambiguous, so there should be always one meaning of, or one objective of one requirements. So there should not be multiple explanation or meaning for a requirements. And the requirements document should be structured, also the requirements itself. So it should be well organized so that the related requirements or the requirements who are dependent each other can be grouped together or identified easily. And also the requirements should be traceable. So if there any relation between requirements and the design and the requirements and the people, or requirements with the any system component, it should be traceable. So we should know who proposed these requirements and why. And also the last thing, as a whole, requirements document or the individual requirement should conform to the standard. So this is the least important thing for the validation, but this is also important for the regulators or other other stakeholders who wants the requirements and the requirements documents to follow the standards. So one of the validation approach in the spiral figure that I showed is use prototyping. And prototyping basically gives you a visual representation of requirements. So when you are writing the requirements, you just see the text, you just read the text, but it's hard to visualize the requirements. So if you do prototyping, it will not only give you a visual representation of the requirements, but also it will give you scope for the experimentation. So you play with the prototype and you find problems with the requirements. So the benefit is like, as I mentioned, it can help to discover problems within the requirements and within the system, and you can easily find improvement scope within the requirements and within the system. Then also you can use this prototype. So prototype is basically a demo system, what we can say in a simple term. So if you can use this prototype as to develop a system test, because in the beginning you have requirements, but you don't know anything about if it can be tested or how it can be tested. So if you have a demo system, let's say a prototype, you can do that. You can define your or develop your system test. And also an executable prototype can serve as a stopgap system. So is there any delayed or is there any failure in the actual or live project or the actual system that you will be delivered? So this prototype system can be used as a intermediary solution for the end users. So you basically provide these prototypes to the end users and let them know that I am still solving my problem with the actual system. Until that time, you can use this prototype to achieve your goals. And also, since when you are developing or working or experimenting with prototype, you are basically carefully reading the requirements. So it will help you to identify inconsistencies and incompleteness within the requirements. So this is also a good chance to find the problems in your requirements. That means to validate your requirements. But for some types of system, like if I would say I am developing a financial system for the university, and it has all the structures to test, all the features to test, but as a demo, this system can be used to test the requirements as a prototype, but this system can be also extended as a final system. So we don't need to start with another system to develop the final system. So the prototype can be used to extend and deliver as a final system. So there are multiple approaches for developing this kind of prototypes. As I mentioned also before, prototyping is a part or is a way of requirements validation. So you represent requirements visually. It can be in different way. So one of the cheapest and common way is using the paper prototyping. So what you do, you basically draw different interface and functionalities on the paper, and this is basically a mock-up system. It cannot be executed, but at least you have an idea of what the interface will be and what will be the requirements in the system. And this is one of the cheapest way of prototyping, but at the same time is very effective. Then paper versions of screens, so those interfaces can be drawn and presented to the end user, and end user can look at them and analyze them for what requirements further they might need, or what requirements are incomplete, or what requirements can be changed to something else. So there is the benefits of using prototyping. And also analysts and end users can work through the scenarios. So once you present the scenarios or interfaces to the end user and analyst meet, and they discuss what were the user expectation and what information they were looking for more, or what is missing there in the interface or in the requirement. I will show you an example. So for example, there is a requirement that Joe wants to listen to a radio program, but not from her laptop. She has radio devices. She has multiple radio devices, and she wants to listen radio on those devices or any of the devices. So let's say we can implement this requirement in two ways. So let's say we have a device, a smart device. So we can send the stream to that device from the laptop, and then that device can play by itself. And we can also give a command to that device. So if we can tell the device that play this music, it will start playing. So how the prototyping would look like for this kind of scenarios? So this is a simple example. This was basically a case study from BBC, and they found that this kind of paper prototyping helps a lot to develop systems and to develop systems requirements. So in the first picture you see, so the Joe navigates to the home page, and she selects the button here, and this button is called Media Escape. So the application the name of the application was Media Escape. So she selected the button. Then when she selects the button, there is another screen. This is also, so all the screens are drawn manually. So there was another screen that gives different devices, available devices. So it shows how the interface may look like. And she chose, let's say, one device that he has with her. And then the connection will be made. So from her laptop to that device, there will be some message for the connection confirmation. And as soon as the connection is established, the music will play. She can close her laptop in the right bottom, and also she can do the same thing from her phone. So let's say smartphone. So she has an app. She opened the app, and what it will look like when she open the app. So she might have TV, radios, tablets, or whatever. So if she selects TV, the radio will play on the TV. So these are the 6 or 8 possible user interfaces and functionalities that you can show on a paper prototyping, for example. And this is a very effective and cheapest way of prototyping, but it's not executable for sure. So one, you draw these scenarios, you go through with the analyst, and you discuss with the interactions, the reactions, and the informations that you are looking for. And there is another prototyping approach, that is Wizard of Oz. So it's more kind of visually appealing than paper prototyping. What it does, it takes input from the user. It kind of process in the behind those input, and someone behind take this input and process it and produce some kind of output. So it's kind of more interactive prototyping compared to the simple paper-based prototyping. So I have a simple or interesting video. I will show it during the lecture. So it's also a cheap, like you don't need to really develop anything. You also rely on papers, and you rely on demo interactions. And then the interactions, what appears to be from using the user's input are basically not taking the input. You just pretending that someone is taking your inputs and someone is doing something behind the system, and you are generating an output. And also you can follow this prototyping method if you already have a system and you want to extend or improve or build on top of this system or interface. And from this prototyping method, we can clearly see the interactions. So, but before, from the paper-based prototyping, we could not see the interactions. But now we can see the interactions with this Wizard of Oz prototyping. But still, it's a paper-based approach. And of course, you can see the functionality or the requirements. So here is a video. So I don't know if you get the sound. So this is a diet application, and you can, so this is the home page of the application. So you can either log in your Google or Facebook. You can sign up using your own data. So I think you are not getting the sound, right? So that's what it says. You can either use your Google or Facebook to log in. So if you sign in, you give your data in the next window, and you sign up using your data. And then there is the login page. So using the user interface and password, you log in. And once you log in, you go into the home page. So you see, it's kind of interaction between user and the input, but we are pretending that once we are giving the input, something is coming up, but we don't know what's happening behind. But it still is paper-based and more interactive. So there can be a side menu. So you go to the side menu, let's say, and in the side menu we have it might have different options. So one of the option could be, for example, tracker. So where you give your weight and height, and it tracks your BMI, body mass index. And similarly, you can also, let's say, go back to your home page. So if you want to go back to your home page, what you will do, you basically find the paper or deck of paper that you had, and you just simply uncover that home page. So this is a easy way and also effective way of identifying requirements and to show and play with the users how to use those requirements. And user can suggest any improvement, and they can suggest if the requirements seem to be valid or not. So there is other approaches, of course, that is called automated prototyping. So the previous two approaches rely on papers and drawing interfaces on the papers, but this one concretely rely on the development of the program. So you can use some fourth generation language. Those are basically even higher level language than Java. So Java, C, C++, all those are third generation language. So you can use those languages like Visual Fox Pro or Visual Dataflex, and there is SQL also you can use, and there is other systems from IBM and Microsoft. So you can use those high-level language to develop an executable prototype. So that is interesting because you can use this executable prototype as a future actual version of the system. And of course, this is expensive because you are using the resources, you are using developers, you are using testers to develop this prototype, and it actually have the actual function or functionality or real functionality compared to paper-based prototyping. So there are different methods for developing this kind of automated prototypes depending on what types of system you are developing. So one of the common or most known ways using 4G languages that use data. So these days, all the systems and applications, they are data intensive. So if you are developing a information management or application that deals with data, you can use these 4G languages. So for example, Visual Dataflex is one of the most common way of developing this kind of systems. Then if you have a system that needs reusable objects, for example, in Visual Basic, you can design a form using buttons and fields and text, and this form can be reused many times. So for those kind of systems, you develop high-level languages like Visual Basic. Then also you have internet-based prototyping. So those are basically browser-based prototyping where you can use Java. And as you know, Java provides applets. So those applets are basically user interface with data and other buttons similar to Visual Basic. So when you execute because the main problem is Visual Basic cannot be executed in browser. So when you executed those applets in the browser, you can test the system as a web-based application or as a browser-based application. But there are some requirements that cannot be basically prototyped And those requirements are basically non-functional requirements like performance, efficiency, reliability, and usability. And that's why this prototyping method is only good for extracting or analyzing or discussing functional requirements. So non-functional requirements are not goal of this, or not the focus of this prototyping method. So once we have a prototype, and there should be a guide or guideline that can be used while you are playing with the prototype, let's say the automated prototype. And for that one, you need to write a draft user manual. So these days, every software or every program comes with a user manual. But that's the reason that you should have a draft user manual while you are developing a prototype. And also, this draft user manual can be delivered as a final user manual as the systems evolve from prototype to final version. So what to do this, or to write the draft user manual, use or start with the requirements document as a specification or system specification document. And for each of the requirements, you should write how to use them. And while you are trying to write how to use them, you can visualize maybe, or you can imagine how the interface will look like, and you write the use of the requirement accordingly. So you have to make it basically a plausible assumptions. And if you are writing this user manual for a prototype, you don't have to make assumptions. You can rely on the prototype that you developed to write the user manual, or draft user manual, I would say. So what are the benefits of this draft user manual? So since user manual forces you to analyze all the requirements, or to read all the requirements carefully, it will help you to identify usability issues as well as the problems in the requirements itself. So that's the good part of writing a draft user manual, because not always you are carefully reading the requirements, but here you are reading the requirements to write their how to use them. So you may find some more problems while you are writing the user manual. And also, this user manual, as I said, it can be helpful for the people who are playing with the prototypes, so they can test the prototype based on this draft user manual. And also, this draft user manual can be converted later to a final user manual when the system will be delivered basically. So how to implement this? It's very easy. So for each requirement, you have to systematically translate the functionality that was described in the requirements, and you should use end user terms. So you should not use technical terms, since end users will be the final user of this user manual or this manual. You have to use their general or common terms, and basically for each requirement you have to explain how to use them from the system perspective or from the perspective of the prototype. So not only a draft user manual will be helpful, but also if you generate draft test cases, so let's say test cases, it will be helpful for the software testers at the end that which requirements should be tested how. So what you can do, you can propose one or more possible tests to check if the system or meets the requirement, or if the requirements are meeting the objective that we wanted to meet. So what's the benefit? So it will also find the incompleteness and ambiguity within the requirements, because if you find a problem in the requirements for which you cannot define test cases, that means these requirements were not well defined. It might be incomplete. It might be ambiguous. Written. And also this draft test cases, or this requirement test cases, can be used in the final phase as a test planning, so the software testers or testing engineers who will be testing the final requirements or final implementation at the end, they can take these draft test cases for their planning or for testing the system. And how to implement? So basically, we for each requirement in the requirements document, we define a test cases which will. So here we are basically define the test case. Is it in a text? We are not defining test cases in JUnit, for example, in Java. So we are defining a test which can objectively check if the system satisfies the requirements. So the test engineers will read this test, and he will convert this test to the test cases in a programming language. So, and also the objective of proposing test cases is to validate the requirement. So this is another way to check if the requirements is correct, rather than validating the system itself. So we are defining the test cases as individual requirements, not as a system as a whole. And also, while we are defining this kind of test cases, these draft test cases, it does not consider like any other factors like testing cost, that we might have redundant tests, we might have issues with the test data. So it does not consider any of this. It just simply mentions or defines how these requirements should be tested. So these factors of testing cost and redundant test and other test data issues will be taken care of by the testing engineers at the later stage. So how to define the test cases, or maybe well-defined test cases? So if you want to define a test case that is objectively able to test the requirement, you should ask several questions also. So you can also use the context or use the scenario of the requirements. So which context or scenario these requirements will be used. Then you also need to know, does this requirement have enough information to write a test? Because sometimes requirements are incomplete, and it's hard to write test cases for incomplete requirements. Then also, is it possible to check the requirements using a single test, or you need multiple test cases? So if there is a need for multiple test cases, that means your requirements can be broken down to sub-requirements, because you have multiple embedded requirements in a single requirement. And can the requirements be restated so that the test case obviously works obviously? So you have to make sure that the way you write your requirements, if you change it by keeping your objective the same, it does not change the test case. So the test case should be one, but it can be applied to a requirement that can be written in many ways. So that's the thing here. But also finding, if you can define a test case, after finding it, you should also design a test recording form. So for each requirement, you should propose a structure that will basically make a traceability link between test cases and requirements. So in that form or a structure, you should identify, you should have identifier for a requirement. So basically, every requirement should have identifier. And then what are the related or dependent requirements for that test cases? And then brief description of the test case, which will check the requirements objectively, and why these test cases will be helpful and how. And also a description of the requirements problems. So if you have any requirements that are not well written or not, that are incomplete, you should describe those in this test recording form, because this test recording form will be used by the test engineers later on. And also the recommendations or possible ways to resolve those problems, so that this can be used for the developers, by the developers. So one of the way of requirements validation is to paraphrase system models. So you might have different models or diagrams, but if you describe them using natural language, it will help to get the meaning of those models. And not always all the people are technically expert or are known to models. So for example, managers or end users, they are not really familiar with the models. So you should write those models into natural language text, so that you can validate the requirements in a more effective way. So, for example, as I mentioned, the benefit includes the stakeholders like end users or management, or external stakeholders like regulators. They are unlikely to learn or know those notations in the models, so it's good to write them or describe them in text. And also, while you are paraphrasing or describing your models, you are basically thoroughly analyzing your models and requirements at the same time. That means there is a high chance that you might find errors or inconsistencies or incompleteness in the model, so thus in the requirement. And how we can do that? You can use simply tables or forms describing different components in the model. For example, for the data flow diagram, you can use a template for each transformation. So I will show an example here. For example, for this data flow diagram, this is an online delivery system. So it takes orders from the user, it processes the order, and it shows how different data are flowing among the different activities and processes. So at the end, user is basically getting the product here. So the transformation name can be the model name, or you can give any name that is related to the model. So then you also need to define. So when the goal is to describe this model in a natural language text. So in the second phase, you need to define the inputs and input sources. So what are the inputs of this model and where those inputs are coming from? So let's say one of the inputs is the order details. So it's coming from the order. So this orders is the input to the process order. So one of the input can be billing information. So billing information is the input for invoices, but this is coming from the process order. So you need to list all the inputs and their sources. Then also you need to list all the transformation function. So for example, this process order is a transformation function. So it takes the order and it produces a bill information. So it's doing something. And also the outputs in the same way of inputs. So what are the outputs of this model or of this process model and where it's going? And also finally the control. So control can be any decision or any logical box, but here in the model there is no control. So let's say here can be a control after the users receive the product, that if the product is a good condition, or if the customer is happy with the product. If it's not happy, it can goes back all the way to the new process or new order. So in this way, you can describe a model in a natural language text. So this was until the requirements validation. So for requirements validation, we looked about prototyping. We looked about the review and how to form the review team to read the requirements and to discuss and agree on the requirements. So now we will move to the requirements management. So what's the time now?
10:11.
So if you want, okay, I can continue because it will take some time. Because if I have a break, it will take even more time. So why do we need to do the requirements management? And since requirements that are elicited or proposed or gathered, they might change over time, and new requirements can come up from the stakeholders. So there is a strong need for requirements management. And once there is a new requirements or change in existing requirements, this should be reflected in the system, and it's also true for vice versa. So if the system changes in some way or because of anything, the requirements or corresponding requirements should be also changed. So requirements management is a process. So again, it's a part of overall requirements engineering process. So it's also itself is a process that supports what are the requirements engineering activities will be part of it, and sometimes those requirements engineering activities like elicitation and analysis or validation or traceability information maintenance, so those will be carried out in parallel. So there is no order between them. And in a survey with 4,000 European companies, they found that one of the key problems in the software engineering is the problem with the customer requirements. So customer requirements, they are not well managed, they are not well represented, they are not well defined. So this is one of the major problem in software engineering domain. That's why requirements or quality requirements management is important. So what are the primary concern in software requirements management? So the primary concern or goal is to managing the changes to the requirements. So there can be changes anytime. So managing the relationships between requirements. So most often, or maybe always, requirements are dependent each other. So we have to maintain this relationship or manage the relationship between the requirements, and also the managing the dependencies between the requirements document or the requirements with the other documents or other part of the system. So it can be dependencies between requirements and any design component, or requirements between any stakeholders, or requirements with any source code, for example, even. So we can easily know which source code implement which requirements. So maintaining this requirements traceability information is the key to manage requirements. So if you don't have this traceability information, so by traceability information I mean who suggested or who proposed this requirement and why he proposed this requirement, based on or based off what need, then what are the related or dependent requirement, and how these requirements related to other information like system design or implementation or user documentation. So all this information or all these dimension, I would say, are linked with or known as traceability. So if we know who suggested the requirements and why, and the related requirements and how they are related, so we have well traceability information, but we also need the management of this traceability information. So one of the goal, or one of the, I would say, prerequisite of managing requirements is to identify each requirement. So while you are managing something, you need to identify it, right? So you must assign a unique identifier or reference number for each requirement, and in this way you can basically search it. If you have a database of requirements, of course, you can use this identifier as a primary key if you want to work, or if you want to operate on those database based on this primary key, and if you want to analyze requirements, and if you want to search requirements, if you want to group requirements. So basically all kind of database activities of the requirement database, you can use this primary key, and the primary key is basically the identifier of the requirements. So all the identifier of the requirements should be unique. And also, if you are versioning the requirements, this identifier might have versioned and you can easily take any single identifier and any single version and know which requirement it corresponds to. So this versioning is also important in configuration management system, because it keeps all the versions for all the artifacts in the software design. So the most common approach or way to identify a requirements is to assign numbers. Let's say you have a sixth requirement in the second chapter, in the second section of chapter 4 can be identified at 4.2.6. So it's in the fourth chapter, second section, and number 6 requirements. But there is a problem with this method of identifying requirements. So if you have another requirements, let's say 3.2.6. So in the third chapter, second section, 6 requirements. It might seem that those 2 requirements are similar, but in reality they can be completely opposite, or they can be describing a completely different requirements. So this numbering method is kind of ambiguous and not very clear. So the one good way of identifying requirements is to use this mnemonic form. So if a requirement is something about security, you can call it SEC, SEC, and then give a serial number, for example. If it's a requirement is about database, you can call it DB, or so you can grab the keyword from the requirements, and you can use that keyword to identify your requirements. So I have a number of slides on the policy. So there can be different kind of policy for requirements management. There can be policy for requirements traceability information. There can be policy for requirements validation itself also. So what is this policy? So Cambridge Dictionary defines policy as a set of ideas or plan of what to do in a particular situation. But this plan must be officially agreed by the people or the organization. But also Business Dictionary defines policy as a set of principles, rules, and guidelines that we need to follow and to achieve long-term goals. So this policy, or this definition of policy, also applies to software engineering community. So in particular requirements engineering community, because we need to have policies for everything. So a defined process or a structure. So requirements management policies define goals for the requirements management in the first place, and also what are the procedures we should follow, and what are the standards we should conform. So these are the main 3 dimensions of policies, or defining the policies. But there is also multiple benefits of defining policies, because if you define a policy, it will guide people what to do and why and how they should do it. And also in this way, people will be less dependent on each other. So they will just follow the policy and they will work on their own. But also to define a policy, you need to understand the existing policies or existing processes of the requirements management. So that is also more likely to find problems of your problems within your existing processes or requirements management processes. So if you define a policy for requirements management, you know your processes well, and while you are defining your policies, you find the problems in your requirements management processes. So these policies are basically are the basis of the quality management of the system requirements. So if you follow these policies, they will ensure that your requirements are high quality and your system will be high quality as well. But what are the differences, or what is the main difference between policies and standards? So it seems similar, but they are not, because policies says what should be done in a certain context or in a certain situation, but standard describes how to use those policy to, in a certain context. So there is this difference between what and how. So policies are basically organizational specific, but standards are not organizational specific. So all the organizations apply their own policies for a particular situation. So what are the goals, or what are the good or benefits of defining a policies for requirements engineering, requirements management, let's say? So the general requirements policy should define or include a set of objectives for the requirement process. So we should have a clear objectives, why we are going to define a process or define this process, and rationale of each of these activities or objectives. And also there should be a list of report that will be generated as a part of this policy or for requirements management. And also what are the standards we will be following for this requirements management as a part of this policy. And what will be our change management policy? So requirements management also includes change management. So how we will accommodate, or how we will make the changes if there is requirements changes in the requirements. And then there is also requirements review and validation policies. And traceability and information is also most important in requirements management, I mentioned. So what information on traceability we will be storing, and how this information will be used and managed in the future. But also the criteria when these policies will be ignored. So if we have urgency of delivery, if we have some exceptional events, we should mention also those events and how those events will be handled under this policy. So to define requirements traceability policies, so what information will be maintained and how it will be represented. So to find this, so the first thing to know is the traceability information can be dependencies between requirements. So requirements can be dependent on another requirements. It can be between requirements and the system design. So we need to know which system design was designed as a part of what requirements, and also the requirements and the components. So we need to know which component was designed or is related to a requirement, and also the requirements and the documentation. So in the documentation or user manual, it defines all the requirements on how to use the requirements. So there is also traceability between requirements and documentation. But traceability information or traceability policies, I would say, are written policies basically that define the following. So what it defines, those traceability policies. So it defines the traceability information, so what information will be maintained. Then the techniques for traceability, so what techniques will be used, and also when the traceability information should be collected. So it's not always collected at different times. You should be collected at a certain time. So in particular, during the requirements validation and analysis phase, and the roles of the people in different stages. For example, the traceability manager, who will always be responsible for maintaining and traceability information, and also how to handle document policy exceptions. So if there are any time constraint, how this traceability policy will be considered. So we might also ignore traceability policies if we have time constraints. So it's better to always have a simple policies that are easy to follow, rather than a complex that managers always try to avoid. So these are the type of traceability information we need to put or focus on in our traceability document or as a part of our traceability policy. So the first type of traceability is requirements and sources. So there is a link between requirements and sources. So link the requirement and the people who proposed it, or the documents who describe this requirement. Then also the requirements and the rationale link. So there should be a link between the requirements and why the requirements was proposed. There should be also a link between requirements to requirements. So the requirements dependence. So one requirement can dependent on another requirement. And also between requirements architecture and design. So there is a slight difference, or maybe big difference, between design and architecture. So you should have links both between requirements and design and requirements and architecture. So design is more about a specific component or a specific class. So we should have a link which class design which requirements. And also architecture is more about high level. So it's about a subsystem. So you should also have a link with those subsystems with the requirements that they are implemented. And also finally the links between requirements and interface. So if you have any external interface or external subsystems or systems you are using in your implementation or development, you should make a link between those subsystems or interfaces and the requirements. So which interfaces require or helping which requirements, let's say. So there are some ways, or basic ways I would say, to maintain this traceability information. So one of the most simple and common way is to maintain them in a table. So you can use a simple matrix, and this matrix gives an example. For example, R1, R2, R3, and R4. And while you are reading this table, you should read it column wise. So R1 depends on R4, R2 depends on R3, R3 depends on R1 and R4, and R4 doesn't depend on any requirements. But this traceability information is very general, so it does not define or specify what kind of dependability it is. So what we can do, we can go further and classify those dependencies. So it can specify one requirement can specify another requirement, and one requirement might require another requirements, and also one requirement might be constrained by another requirement. So if we represent the same matrix using this specific types of relationships, you can see that whatever we say that R1 depends on R4, here we saying that R1 requires R4. So the output of R4 will be input of R1 basically. So in the same way, R1 is constrained by R3. R3 specifies R1 because R1 requirement R1 is not sufficient alone to describe itself. So R1 complement R1, and also R1 constraint R4. R3 constraint R4. So in this way, we can specify the relationships in a more specific manner. But this approach is good for a small number of requirements, because you cannot have a large table with 100 requirements or 200 requirements and then do everything one by one. So to overcome this problem, there is another approach, that is traceability list. So where you basically maintain a list like this. So instead of having a matrix, now you have a simple list where for each requirement, so it doesn't matter how many requirements you have now, you simply mention which requirements they depend on. And this is more compact, so as you can see, it's more easy to represent, and also it's less error prone. So it's less error prone than matrix, because you simply list the requirements that depends on certain requirements. But you need to, for this kind of list, you need to represent for if type of relationships. So if you have a relationships for the previous slides, if we have a relationship for specifies, so you should have a separate list for specifies. So R4 specifies R1, R3 specifies R2, for example. But you can also have a separate list for constraints or requires type of relationships. So disadvantage is that, but good thing is that you can easily find from your left right. So R1 depend on R4, but if you want to find, let's say given R4, we want to know what are the dependent requirements for R4. So for R4, you can see it is dependent on R1 and R3. So what I wanted to say is easy to go from left to right, but it's not easy to say go from right to left. But this list can be converted to a graph. So in a graph, in a way that, as I mentioned before, R1 depends on R4. So you must implement R4 before R1, right? So in the graph, R4 comes before R1. Then R2 also depends on R3. So you must depend R3 before R2. So R3 comes before R2. And also R1 and R4 depends on R3 depends on R1 and R4. So this R1 and R4 must come before R3. So as you can see, there is a sequence of requirements, and this kind of representation of traceability list can also gives you an idea the order in which you want to implement your requirements. So if you want to implement your requirements R2 first in this picture, it will not work because R2 is dependent on R3, so you must implement R3 first, but you cannot implement R3 until you implement R1 and R4. So there is a dependability, and you can follow the list to prioritize your requirements. And also, apart from these techniques for maintaining or managing your requirements, you should also define a database to manage your requirements. So it can be a relational database, it can be any types of database. So the benefit is that you can easily links between requirements. You can search or you can group requirements using this database of requirements. And also, if it is the database is very general, like system database or system information database, you can links not only with requirements with another requirements, but you can also links requirements with other design components and implementation artifacts. And also, you can using this database of requirements, you can automatically process them to extract those kind of traceability tables or traceability lists automatically. That's another benefit. But before deciding if you want to or if you really need to use a database for your requirements, you need to ask yourself these 5 questions. So how are those requirements expressed? So if they are expressed textually or graphically or mathematical notations or other forms, how many requirements you usually typically need to manage? So if you are really managing 10 requirements, you don't really need a database. And are those requirements always developed and managed by the team working at the same time or same site and the same place? So if your team is remotely working and they are geographically located in different places, you cannot really have a centralized system or local system, I would say, that can be managed and used by all the people. But there is, of course, other solutions like internet-based requirements management solutions, but those are really new and not very used these days. But also, do you really use a database for software engineering support? Do you already use? So if you already have a database, you can extend that database for the requirements. And what in-house database expertise do you have available? So if you, for sure, these days, software engineering firms has database analysts. So if you don't have expertise in your company or in your group, there is no need to use a database. So as I mentioned before, so relational database are most commonly used these days, but there is another technology that is or approach that is object-oriented database that are used these days. So these days requirements are not only text, there are models, there are diagrams, there are figures, there are tables. So this object-oriented database is useful to represent those kind of object-oriented requirements. So you also need to define a change management policy. So once we are concerning with the change and how we want to manage those change, we need to have a policy. So we need to have a guideline or principle that we want to, how we want to manage those requirements or changes in the requirements. And to decide on the change, basically if there is multiple change or multiple proposal from the stakeholders, you need for each change analyze the cost and benefit and decide based on the cost and benefit within your team. But the benefit includes that it can control your overall cost for the long run over the whole development cycle. Because if you can control your change and if you cannot control your change, there will be a number of changes, and if you are accommodating all of them, your budget will be over your expectation. And keep track of the status. So if a requirement is changed 10 times, and if you track them, basically you have all the information of how those requirements changed and why and when. And you can, of course, create reports based on those change tracking. And also give stakeholders a formal mechanism for change requirements. So if you have a policy, so policy of course define a well-defined structure that how you accommodate different changes. So if you have a formal mechanism, it will ensure that you are not favoring any stakeholders. Like if there are changes for multiple stakeholders and you want to favor someone by blocking someone else, it will not give you that chance. Is the streaming working? Because the system seems shut down. So the change management policy should include or define how the change request process will be handled, and the process to analyze impact and change. So there should be a clear process that you analyze the cost and benefit of your each of your changes. And also the policy should define who will be on the team of your change management change request management policy, and what are the softwares you will be using. So you can use a change management database, for example. So one of the issue is defining or identifying global system requirements. So we are talking about until now functional requirements, but there are some requirements that are applicable to the system as a whole. So those are basically non-functional requirements, and identifying those requirements as early as possible, it will minimize the future changes of your system. So if you identify in advance, you can plan how those changes will be accommodated, and if it's not too late, it will save lots of your money. And also knowing the global requirements or these non-functional requirements in advance simplify your change process, and you can involve, because if, for example, there is performance issue, for example, you can consult different stakeholders, and because if different stakeholders or consultants are part of the whole development process, and their performance issue will also impact the performance of the whole system. And how you need to identify global requirements. So there is a very simple way if your requirements are global or non-functional. So you have to ask 6 questions, and based on their answers, you have to decide if the requirements is global or not. So the first one is if the requirements is expressed in a very general way, and does the requirements express some global non-functional system characteristics, and is the system, if there is the requirement a general interface or user interface requirement, does the requirement refers to a system functionality, a specific system functionality, or a specific system service that must be provided. So if it's a very specific system functionality, then it's a feature, it's not a global system requirement. So can the requirement be mapped onto part of the system model? So usually a system model implements a feature, and does the requirement refers to a specific data or components of the system? So now if you answer yes to the questions 1 to 3, or if you answer no to the questions 4 to 6, that means your requirements are global requirements. So basically that means your requirements are non-functional requirements. And this process of identifying non-functional requirements will be applicable to every requirement, and that's why it's an iterative process. So you will never get your full list of non-functional requirements until you are done with your requirements validation and requirements document. You also need to identify, as a part of your requirements validation, you want to identify the volatile requirements, so the requirements that are most likely to change, that requirements that are most change prone. And you also not only need to identify the requirements that are change prone, you also need to predict or identify what part of the requirement will be changing or might change. And usually experienced engineers can do that, not developers. And benefit included is that if you identify volatile requirements, it will help the developers to develop them in a loosely coupled manner. So it will not be tightly coupled with other components, for example. And if there is a change request in the future, you just change that loosely coupled component, and the rest of the systems will not be affected. And you always need to update the volatile requirements over time, because some status of the requirements might change over time, and one requirement that is volatile now, it cannot be, may not be in the future. So you should always update the status. And for that one, in your requirements management database, you should have a field that might called estimated volatility, and you can use 3-scale value, a simple 3-scale value, that is 1 for fairly stable, that will not change in the long run. Then there is 2 for the medium term change, so it might change in the near future, and then the 3 is most likely to change in the short term. So that is the most risky requirements. So there are 4 types of volatile requirements. So the first one is mutable requirements that changes due to mainly to the environment where they are being executed or where they are being used. And then there is emergent requirements. So requirements are not always specified or defined in a complete, consistent and correct manner. So they might evolve over time in terms of definition and description. So we call them emergent requirements. And then there is also consequential requirements. So we might define some requirements that will be defined based on some assumptions on the system. So if we are defining a banking system, for example, based on the current context, let's say the bank is very small, and we just need a small database, and we define the requirements in that way. But in 5 years, the bank can be boom, and it can grow a lot, and we need to change the database requirements. So this kind of consequential requirements are changing. And also compatibility requirements. So there can be dependency between requirements and also other equipment and processes. So if the dependency requirements change, the dependent requirements also change. You also need to record rejected requirements, and not only that, and you have to record why they were rejected. And the good thing is that if you record those rejected requirements, in some point they will be proposed again. So you don't need to do the whole thing again. So you don't need to do the requirements analysis, requirements validation, requirements test case generation, user manual, so writing user manual, all those stuff. So it will save lots of your money in terms of cost. But for this one, we also need to have a separate column or status field in your requirements management document, as if the requirements were accepted, or if it is still under consideration, or if it were rejected. So in this way, you can track your rejected requirements, and in the future, basically, you can consult this database if a similar requirement is proposed, and you don't need to do the whole analysis phase and again and validation phase for these rejected requirements that were proposed later on. So the lecture is almost finished, but before finishing the lecture, I want to again give you the key takeaways as before. And the first one is about the requirements validation. So the objective of the requirements validation is to check the sets of requirements to find possible problems. Then for the validation, we should have a group of people from diverse background to systematically check the requirements, and so that they meet and discuss and agree on the possible solutions of the problems. And also, the requirements document team should be multidisciplinary. So there should be people from different background, skills, and knowledge, and not to make the requirements validation biased. And also we need to implement a prototype. So this prototyping approach is an effective way of recurrence validation. So we need to visualize or implement even using 4th-generation languages to prototype a system for recurrence validation. It can improve a lot in the recurrence specification and how they are implemented and tested in the later phase. Also, while writing the user manual, if someone with the experience writing the user manual finds problem to write how to use those requirements, that means your requirements specification has problem, your requirements has problem, and you need to revise your requirements specification. Then for each requirement you should have an identifier. This unique identifier is useful for analyzing, for gathering or classifying requirements, and also to find dependent requirements, for example. And mnemonic form is one of the most commonly used these days also for requirements identification. Then you should have policy. So policy is everywhere in the phase of requirements engineering activities. And you should have also a policy for requirements management that will follow how the change management should be take place, and how the requirements validation should be take place. And also you should define policies for managing changes. So how changes will be proposed, analyzed, and reviewed, if it's using a database or not. And also finally you need to maintain a list for volatile requirements as well as the rejected requirements, because those requirements might be coming up in the near future by other stakeholders. So it will save your cost and time in terms of requirements analysis and validation. So the lecture is over here, and if you have any questions I can go through them.
When is the deadline for the assignment?
The assignment period is not the next week, the following week. So I will be probably not today giving the assignments online, but I think it's let me see, it's in the slides. So the assignment is from the 7th week, so it's after February 8. So the deadline is February 15. So it still have time, but I will be giving the assignment maybe after this lecture, because you will be using UML for your assignments, and it will be good to give you some background of the UML and also the tool. But the tool I will be introducing here is fairly simple, and it will not be hard to follow to use the tool. So after this lecture on February 6th, I will give you the assignment, and you can do whenever you want, but the deadline is February 15. And it will be again open assignment, so it will be more intuitive. So there is nothing to remember from the slides, or it's just if you got the idea of requirements engineering process. Anything else? No question from the slides, Slack? No. Okay, then see you on February 6th, next Wednesday, and have a nice weekend. Thank you.